In the late 17th century, in the quiet of England, something monumental was happening, something that would forever alter the fabric of science and mathematics. It was a stormy night when Isaac Newton sat alone, staring at his parchment, a mystery just out of reach. What if there was a way to measure change, instant change to be precise? Imagine standing on the edge of a cliff, watching the tide rise second by second, inch by inch. You can see the water moving, but can you truly understand how fast or the rate at which it's rising at any given moment? The tides of the sea were a perfect metaphor for a deeper, hidden truth. Change could be understood, but only if you could break it down into infinitely small moments. This was the birth of calculus. At the heart of Newton's discovery was a powerful insight, the idea of limits. What happens when you divide a change into smaller and smaller pieces until they're so tiny they seem almost non-existent? Newton realized that by breaking time and space into infinitesimal slices, you could see how things changed, moment by moment. The equations he wrote weren't just numbers, they were a window into the rhythm of the universe. But Newton didn't stand alone. Across the English Channel, a man named Gottfried Wilhelm Leibniz was working on a similar concept. Unbeknownst to him, their work was converging. The race was on. Would history remember the quiet, solitary Newton, or the meticulous, methodical Leibniz? It was a feud that would stretch far beyond their lives, yet neither would ever fully claim the crown of being the sole inventor of calculus. As the years passed, calculus began to weave itself into the very fabric of physics. Newton's laws of motion, which had once seemed impossible to grasp, could now be calculated, step by step, equation by equation. Calculus provided the missing piece, a key that unlocked the door to understanding everything from the orbits of planets to the motions of particles in the smallest corners of reality. But the impact of calculus wasn't just scientific. It altered the way we view the world around us. Everything from the speed of a falling apple to the forces shaping the cosmos could now be expressed mathematically. What was once a mystery hidden in the vast expanse of the universe had been given shape, and through that shape we could begin to truly see, the forces of nature at work. So the next time you look up at the stars or see the movement of the ocean, remember, calculus didn't just change the world, it allowed us to understand it, piece by piece, and that understanding, it's still unfolding. If this story inspired you, please like, share, subscribe, and comment below. Let's keep exploring these mysteries together.